When you finish with this lesson, you will know what a rhombus is and its place among the plane figures. Identify the 5 features of a rhombus. Recall and apply 3 different formulas for finding the area of a rhombus. Let's begin. What is a rhombus? A rhombus is a plane figure, so it is two-dimensional. It is a closed figure with straight, linear sides. One of the many quadrilaterals, which are 4-sided shapes, it is a special case of a parallelogram. All 4 sides are of equal length, and both pairs of opposite sides are parallel. Opposite angles are equal too. That's it. A rhombus can also be called a rhomb, a lozenge, or a diamond. A square is a rhombus with 4 equal right angles. Sometimes you see a rhombus with 2 sides horizontal, as if a square had been run into by a bus and tilted over. That is a handy mnemonic to remember its name. Run, bus, rhombus. In this presentation, the altitude, also known as the height, of the rhombus can be very easy to see. Sometimes the rhombus is drawn so one of its 2 diagonals, which are the lines connecting opposite vertices, is horizontal, making the diamond shape more obvious. One unusual quality of a rhombus is that its diagonals are always perpendicular to each other. No matter the angles of the rhombus's 4 vertices, these diagonals also bisect each other, which means they divide the rhombus up into 4 right-angled triangles. The squares of the lengths of the 2 diagonals are always 4 times the square of a side. For such a simple shape, a rhombus has many parts and measurements. Knowing how to use these measurements can help you find area, perimeter, and other facts about the rhombus. How to find the area of a rhombus. Let's construct a rhombus with sides, S, and 4 vertices with interior angles, A, B, C, and D. We can connect opposite angles with diagonals, D1 and D2. Connecting one side to the other with a perpendicular line gives the altitude or height. Our rhombus has 4 equal length sides, AB, BC, CD, and DA. 4 interior angles with opposite angles where angle A equals angle C and angle B equals angle D. 2 diagonals, D1 and D2. Only in a square will these be equal length diagonals. Altitude or height. When the rhombus sits with 2 sides horizontal, the height h is the distance from one side to the opposite side. The line segment, perpendicular to one side connecting to the opposite side. Since the 4 sides are equal, if you know the length of any side, S, you know the length of all 4 sides. Since opposite angles are equal, and the 4 angles add to 360 degrees, if you know one angle, you can find all angles. Since opposite sides are parallel, adjacent angles in a rhombus add to 180 degrees. For finding area, you need to know the height, or altitude, h, of the rhombus. Remember that the height is not the same as the length of a side. Let's look at the formula using the altitude and side. If you have a mental picture of a rhombus being a tilted square, this first method will make a lot of sense. If the rhombus were a square, its area in square units would be side times side, right? Well, when the rhombus is tilted, you could imagine cutting off the triangular part on one side of the rhombus and sliding it over to the matching other side, restoring the shape to its squareness. You cannot actually cut up every rhombus you meet, though, so consider what that one constructed perpendicular side really is, the height, or altitude, of the rhombus. So, the first and perhaps easiest way to find the area of a rhombus is to find the length of one side and the rhombus's height. Multiply these and you have the area in square units. Area equals altitude times side. For example, if you had a rhombus whose altitude is 3 inches with sides that are 5 inches, then the area of this rhombus is 3 inches times 5 inches, which equals 15 inches squared. Let's look at the formula using the side and angle. The second way to find the area of a rhombus is by knowing the length of a side, S, and the measure of one angle, angle A or angle B. Here you need to find the sine of the angle, but the formula is still straightforward. Area equals S squared times the sine of A, or area equals S squared times the sine of B. You can see that these two formulas give the same result. Let's look at an example. In a rhombus with sides of 10 yards and interior adjacent angles of 60 degrees and 120 degrees, then to find the area of this rhombus, we would plug this into our formula for area using the side and an angle. Area equals 10 squared times the sine of 60, which is also the same as area equals 10 squared times the sine of 120. Then we multiply these two numbers together. Area equals 100 times 0.866. Then we get our answer. Area equals 86.6 square yards. Remember that for this method, the angle you choose does not matter. The formula is the same for both angles. You just have to pick one. Let's look at the formula using the diagonals. Remember that the diagonals of a rhombus always intersect each other at right angles and bisect each other. That means the two diagonals form two sides of a square that is twice the size of the rhombus. You can find the area in square units of the rhombus by multiplying the lengths of the two diagonals, d1 and d2, and dividing by 2. Area equals d1 times d2 divided by 2. If our rhombus only has the measurements for the diagonals, this is the formula we would use. For example, if our rhombus has diagonals measuring 24 and 18 meters in length, then to find the area of this rhombus, we would plug the numbers into our formula. Area equals 24 times 18 divided by 2. We start by multiplying the two diagonals. Area equals 432 divided by 2. Then we get our answer. Area equals 216 square meters. In this lesson, we've learned what a rhombus is, how it fits into the family of quadrilaterals, what its various parts are, and how to find its area. The three formulas to find area depend on information you know about the rhombus. If you know altitude or height and side S, the formula is area equals height times S. If you know the length of one side S and the measure of one angle, the formula is area equals S squared times the sine of A. If you know the lengths of the diagonals, the formula is area equals d1 times d2 divided by 2.